In this video, we're going to continue on with activity 417. The last video showed us with installing the pair cam into the Automata cams simulation using the Automata box, and we're going to look at adding in a second one. So big thing as we go to look is anytime you go through and get one cam, you're going to notice we have our pair cam as noted from our last video loaded in there, and it is following and going along with the motion that we are needing or that is desired for this particular profile. So I'm going to purposely, as you notice, as you kind of test this out and get this going, the one thing you may want to do before you add a second cam in, I'm going to add a second cam in here, is I want to make sure I'm going to go to Revolute 9, which is the axle. I'm going to right click and I want to say go to home position. So you always want that crank handle. Anytime you're going to add a cam in and you're going to constrain it to the axle or join it to the axle, you want to make sure that it is in the home position. So I'm going to go ahead and open up my data panel, and I'm going to pull in another cam. So I'm going to pull in the Hexagon cam and drop it here into the file. So here's what's going to end up happening. Closing the data panel, we do want to make sure, I'm going to move this up here into place and get it in the right position. We do want to make sure that this is going to be that the follower will be in the lowest position on the cam. So I'm not going to want to install it like this because the points are going to be generating movement as it goes along. So I actually want to go ahead and rotate this 90 degrees. So that way the roller, when I've installed this into the box, is going to go ahead and sit on this flat edge. And it's the points, this right here, these points on the opposite sides, are going to go through and generate the maximum displacement for our movement. So I'm going to go ahead and choose joint. Again, making sure that revolute, I notice the crank handle's in the 0 position. That's what we want. I'm going to choose a rigid, and when I zoom in here, this one you're going to be able to see you want the black circle around the hole and the one with the joint origin chip on the edge. And then I'm going to do the same thing over here on the axle by clicking it, making sure that the cam, that the edge of the cam, the front face of the cam, is going to be flush with the axle. This one here, let me turn to the side, and I'm going to offset this. Now this one here ends up being about 2.25 on the offset to be put right underneath the roller. So it makes these numbers a real nice. And I'm going to say OK. In this position, we are going to now, very similar to how we did before, this process is the same for every cam as we go to put it in. I'm going to go ahead and measure, choose the bottom of the roller. Might want to rotate down because I want to make sure that I choose the face. You'll notice it's highlighting the face. You don't want to click the edge so much as you want the face. And what you're going to see here is when you look, this is going to have a value of 0.475 from arrow to arrow. Again, it is going to pick up certain other points because of the arc shape that is on the roller, but 0.475, I'm going to close. And I'm going to go over here to my slider joint, and the slider joint, if I take a look, is slider 41, and it highlights if I just do a single left click, and I can see what that is. I'm going to right click and choose edit joint limits, or excuse me, I'm going to choose edit joint, but we're going to edit the joint limits here in a moment. So edit joint, we're going to do the offset plus 0.475. That's going to go ahead and drop that roller down to be on top of the cam. And then now what we're going to take a look at is I'm going to choose my Hexagon cam. Let me scroll down in my browser to find it, and I want to go ahead and edit in place. So editing in place is kind of a new feature. I'm going to turn this to the side, and I want to, down in my model history tree, I want to edit the sketch because I want to pull some information. Now here from the center to the outside edge is 1 inch, but the thing is we want to know what's the maximum displacement, what's the largest dimension that we see on the cam. So if I measure from corner to corner, these two opposite corners are going to give us a value, and that distance is, if you zoom in or if you check out here, is 2.309. The nominal diameter of this cam, if I restart the selection, is 2 inches. So I'm going to subtract that value. So that means that when I measure from here to here, as this thing rotates around, the maximum displacement is 309 thousandths of an inch. So I'm going to go ahead and close, finish the sketch. I'm going to finish editing the cam, and then I'm going to take a look at those joint limits. So I'm going to scroll up to slider 41. I can click on that symbol to edit the joint limits. My maximum 309 thousandths of an inch. And then the rest position, I'm going to check and leave it 0. So we always want it to be at that 0 position, and I'm going to say OK. So now, here is the cam. There's the roller. If I go through and rotate that around, I can see I'm getting, with our hexagon cam, we are getting the desired motion as we go along. A little note about this animation, the other thing that you can also do with the Revolute joint, you can right click and on Revolute 9 and choose Animate Model, and this will generate that automatic motion. Now the only thing is with this motion, depending upon your computer and some of the other specs that you have, you may see this animation get a little choppy. And it really depends on processing power of your computer and things like that. So mine does pretty well with it. You're just going to have to see what kind of things you're going to see there as far as that goes. So in the next video, we'll take a look at installing a third cam. We're going to install a snail cam, or also known as a drop cam, into the Automata box. And then we'll end up taking a look at, later on, getting those values from our rulers to make this happen.